So good morning, everyone. Thank you for joining us for day 2 of our Love Data Week series. I'm pleased to introduce the esteemed Dr. Ross Nehm, who will discuss data to foster equity in undergraduate education. Please leave questions in the chat and we'll answer them at the end of the presentation. So without further ado, I'll turn it over to Dr. Nehm.
Well, thanks. So Love Data Week, I think, is a fantastic idea as someone who loves data. And I also care a lot about our Stony Brook undergraduates. And, one of the challenges as a faculty member always is you want to know, am I having a positive impact? And so my perspective, and that's what I'm going to talk about briefly, is that data can provide you with essential insights into what you are achieving in your class. And so I'm going to talk about a core learning objective for one of the largest majors on campus. And so most of you may know that biology, I think other than psychology, is one of the biggest majors on campus. And evolution is a core course and program learning objective for biology. So if we want to get data on something, we should be gathering data on our learning objectives. They're really important to student achievement. And as we know from our wonderful Office of Educational Assessment, assessment is essential to being a good faculty member. We want to always be seeing how we're doing as faculty in our classes. And we also know that demographic background variables, first-generation students, Pell grantees or lower income students, underrepresented minorities, these background variables can interact positively or negatively with what we do as faculty in our classes. So we want to take consideration of that. So today I'm going to be bringing these 4 ideas together and showing you how data can reveal really important insights about what's happening in some of our classes. So as a very simple analogy, by the way, I'm going to try to avoid lots of complicated statistics. We can think of learning in this kind of cartoon simplification. You can think of learning as, well, where do you start a race? Where do you end up in a race? And how far you traveled? Now, this seems really simple, but it gets actually quite complicated. So for each individual, we know, and I think you can see my cursor, for example, this person in row number 2, we can see started the race a little bit further behind the person in lane number 3. We can also see, though, that these two seem to have traveled pretty similar distances. So these 3 variables, where you start at the race, you can start ahead or behind or at the starting line, and you can end at different points, and you can travel different distances. So there are 3 key variables then we want to think about when we engage in instruction. Now, recently, just in the last couple of years, a lot of researchers in undergrad education have basically applied this framework. It has much more complicated statistical jargon, but essentially it's about the start, end, and travel distance. And really shockingly, this paper came out last year by Nissen et al. And it's the first study to really look at all 3 factors in very sophisticated quantitative detail. And a study of many undergraduate biology classes, molecular bio in particular, that looked at a core learning objective. They found that underrepresented minorities, first-generation students, and females all, well, as a group, there's obviously variation in every group, they started further behind, they traveled a shorter distance, and they ended up even further behind in the race than when they started. In chemistry, interestingly enough, research has shown that these patterns vary dramatically across different classes. Some classes seem to be helping students travel super far. Others cause them to actually travel short distances in learning, and others make the gaps worse. So these three variables are a great way to think about what's happening in our classrooms. The same is true in physics. It depends. Some classes reduce the gap, others perpetuate the gap. So you can see as instructors, we are controlling the race. We don't control where students start, but we control their distance they travel and where they end up. What happens at Stony Brook? Do students start off at different levels at the starting point? Do they travel the same distances? Where do they end? We don't know. So recently, I conducted a study with my postdoc, who's now a professor at San Diego State University, Jenna Speglia, and we studied 11 semesters of introductory biology to answer this question. And it was a really stressful question to answer personally because I've invested a lot of effort into the class, but I really wanted to know, am I really helping things? And how am I helping things? And how could I use the data to really do a better job at what I care about, which is helping the students? So what happens at Stony Brook in general in terms of assessment? Well, in most classes and for most of my colleagues, assessment is focused on the end of the race, that is a learning proficiency at the end. So we don't really know what's happening in terms of whether we're making these gaps bigger, smaller, or maintaining them. Basically, we don't assess the starting points, making it very hard to know the distance traveled to getting to the end point. So that's what we investigated. And so what we did is most faculty develop their own assessments of learning objectives. Well, because we're obviously, we've got a horse in the race, right? We want to make sure that we're not developing assessments of our core learning objectives that could be biased in some way. So we actually found 3 high-quality, validated, and published instruments that have been used for more than a decade to study learning, to make sure that we had a really rigorous measure of learning that was not biased by our own factors. So there were 3 instruments, although 2 of them, the SINS and the CANS is kind of an improvement of the SINS, so it kind of measures the same thing, but it's a little bit better. And then we have the ACORNS instrument. So we studied overall 11 semesters, and because the SINS and CANS are interchangeable, we just wanted to indicate, though, how many semesters use each one of those. And we studied about 3,500 unique students. So this is a huge study. And we measured the starting point in the race, the distance traveled, and the gaps. So we're basically studying the race using these validated, really robust measures of a core learning objective. Again, everyone across the country realizes that evolution is a core outcome that we need students to understand. So once we do those measures, we have to put them in some kind of framework. And so we developed a new conceptual framework, and that's what I'm going to go over next. And what I'm going to do is basically dump the data that I've been talking about in this framework. So let me walk you through the framework a little bit to make sure that you understand what it means. So the first thing we can do is we can measure in a quantitative sense. We use hierarchical linear modeling, which I'm not going to go into, but it's basically a statistical technique that controls for a lot of background variables in learning. And when we measure learning, we can use something called an effect size. You've probably heard about statistical significance, like is it significant or not? But effect sizes are even more powerful because they basically tell you whether the statistical difference is meaningful. And so there have been benchmarks established for about 50 years about how much learning in a classroom is meaningful, and is it a small amount, a medium amount, or a large amount? So these are across the world, these are standard quantifications of how much learning is happening. So that's what this axis is. So you can see here In this box, we would have small learning. So if a semester has small learning, we would plop that semester in that box. So now let's look at this axis. So educational debt was theorized by Ladson Billings a long time ago, and it's a way of thinking about the disparities between groups. There's no defensible reason why any group should differ as a group. Now, certainly there's individual differences, but no group should differ in the amount of learning that they achieve in any educational setting. So what we can do is, and this is what Ladson Billings did, is she theorized that clearly there are inequities occurring that are causing differences between groups. And she framed that as educational debt. And it's not the debt of the individual. It doesn't take a deficit view of people. It basically says the structure of society is basically loading debt on individuals. That is, and society owes those individuals. They owe them. So it's a debt to society, to individuals. So it's a nice asset-based view of thinking about these disparities. But let's get to the crux of what this means. So essentially in the race, getting back to that metaphor, exacerbating debt would mean that by entering in my course, if data fell into that pattern, I'm actually making these debts, these gaps, even bigger for students. Maintaining means, well, I've kept the same pattern, the same gaps, the same distances that students had between the start and end of the race. I'm maintaining those through the class. And mitigate means I've actually gotten rid of any gaps between people that occur. So putting these two together, because keep in mind, you can mitigate gaps, maintain gaps, or exacerbate gaps with a little learning, a medium amount of learning, or a large amount of learning. So in other words, the distance traveled is different than the disparities in distance traveled. Those are two different things. So this is the framework. And on this axis, this is the frequency of semesters. So we're basically going to look at 11 semesters of data using robust measures at the beginning, the end, and distance traveled, and we're going to populate them using the instruments. So what did we find? So first of all, what variables did we look at? So again, the learning pattern was measured using different instruments. Here are the findings for the ACORNS instrument. So let's first look at this axis, small, medium, large. Each one of these numbers is a semester. So these are not students. So this means 11 semesters, we basically had very large learning gains, or 9 semesters and 2 semesters. So again, this is the distance traveled. So the first conclusion we can say is, wow, students traveled a huge amount of distance, which means they learned a ton in this class. But now let's look at this educational debt pattern. What happened to the gaps between students? Well, we can look at them in terms of a bunch of variables. We can look at race, ethnicity. We can look at gender. We can look at Pell eligibility. We can also look at the amount of bio they completed previously within their educational experience. And so each color corresponds to a different group. And so now we can look at this debt pattern and what's happening. Well, the best situation we could possibly imagine in higher education for our learning objectives is getting in the gold box. We would have large learning outcomes and we would mitigate all gaps. The second best outcome that we could ever get is to maintain, not make things worse, but to maintain the gaps, but help everybody travel far. And that's where most of our data fell, in this second best outcome. So there's good news and bad news here in terms of the outcome. We did not mitigate the distances that were there, but everybody ran the race very, very far. The worst case scenario that prior research has shown for introductory biology classes falls in the black box. There's small learning and everything is getting worse. This is the standard in the research literature of what's happening in classes. Here's what's happening for the acorns at Stony Brook. But now let's look at the second instrument. The second instrument reveals some interesting and slightly different patterns. This is very interesting to me because both instruments are intended to measure the same learning objective, but they do it in slightly different ways. The SINS is a measure of knowledge, and the acorns is a measure of performance. So it's a performance assessment versus a knowledge assessment for the same learning objective. So it provides a rich perspective on this really important learning objective. Well, look at the SINS. So for knowledge, we actually got 3 semesters into the gold box. We didn't get a prize, but we did get in the gold box. So the other good news is that we mostly had large learning objectives, but in one of the semesters, we actually only had medium learning outcomes. So for this instrument, again, we saw great magnitudes of distance traveled, and we saw that the incoming debt was maintained but not made worse, except in a couple of semesters. So in terms of research on learning in undergrad settings then, getting back to the race metaphor, at Stony Brook, for this core learning objective, which is essential for every biology major, you underrepresented minorities, first-generation students, and females start behind in the race. But they travel huge distances, but those distances are still maintained. So at the next level of coursework, they've made it further, but they're still behind. So there's a couple ways of looking at this. This is much better news than the only other research on bio courses in the United States. So this is pretty good news for this, but it also shows we're failing in a key aspect. We are not eliminating these gaps. So in other words, all of the students are being pulled up hugely, but they're still behind. The distances between them have been maintained as they move forward. So they're still at a disadvantage. So it helps us to pinpoint what is the problem with our course? Is it the learning magnitudes? Is it making the gaps worse? Or is it maintaining the gaps? This assessment information is essential to knowing how to improve courses. So what are the implications? I think some of you may say, okay, well, that's great. You learned a lot about what's happening in biology. I don't care about bio. I'm in this program and I'm trying to solve other problems. Or maybe you're thinking, well, what does this have to do with assessment policy in general? So my argument based on this data and from using it, these are the following. Focusing on the end of the race. If I only looked at the end of the race, I could not have learned where my students are when they come in. I couldn't tell basically how far they've traveled, and I could not tell if I'm eliminating or exacerbating gaps between students. So if we really care about our students, we have to understand what we are doing to them in terms of sort of this race that they're all involved in. It helps us pinpoint reform and know how to address inequities. I think that's a key point. And so I'll end there so we have time for questions. I just want to thank my amazing collaborator, Jenna Speglia, and all of the students that have helped with this huge, huge project. And a final note, the National Science Foundation has awarded $500,000 to San Diego State University to bring the model I developed here at Stony Brook there to see, because their learning outcomes are horrible. Basically, in bio, they did a study and found not only was there no learning, the gaps got worse. And so the Stony Brook model that we've developed for 201 is now being taught to thousands of students at San Diego State, and we're studying the impact that this has on the learning outcomes. So I think this model has a lot of exciting implications for making us all better at our jobs and forcing us to really look at data and why we should all love data. So I'll end there.
All right, thank you. Ross, you have a question in the chat. Was the
Sure.
one semester related to the pandemic semester?
That's a great question. In this data set, I do not think we have a pandemic semester in there, but I did do another study and we definitely found the semester of the pandemic. That is, this was in spring semester. The learning outcomes were very poor. But the problem is that semester, we had a big pulse of students, and the university made us go back into Javits, into a huge lecture hall, whereas the class is more, it's a collaborative workshop class where we don't have large lectures anymore. So we're confounded by the pandemic happened in an instructional setting that was bad. So it's very hard to know if it was the pandemic or the Javits kind of. I don't know if that answers the question.
Okay. Well, I have a question. So I saw that in one semester you have 3 in the gold box. So what are your recommendations to get more students into that gold box?
Yeah, I mean, because we know that learning is great, which is unusual based on the research. Although a lot of people haven't looked at inequities, they have looked at learning, and learning of evolution is very hard to achieve. And in fact, it's not included in this study because we didn't have as many demographics, but 12 years ago, when I first came to Stony Brook, we did a measure of the class before we reformed it, and the learning outcomes were small, very small. So in this case, what this indicates is we don't really need to change the learning in general in the class. We have to provide more support so that students can basically catch up even further than other students. So one idea we've been thinking about is kind of a supplemental instruction where we add on some extra resources for students who we know start the race a little bit behind, so that initially we give them more supports to get them a little bit further along early in the race to help them catch up. So we're really thinking about the unique strategies that we need to move students from maintain to mitigate. That is, there's a group of students who need to get further and they start further behind. And so we're thinking about what course resources can we build to help them move along. I don't know if that answers that.
And Catherine, I see you have your hand raised.
Yeah, so, and actually my question is kind of aligned with that. I was wondering what other variables were included in this analysis, right? Like how many students perhaps were taking advantage of tutoring opportunities, or perhaps they were taking other classes that were also helping them in this course. So I'm wondering what other variables you guys used, when it came to actually finding out the outcomes.
Well, we do know about prior bio, and so we controlled for all of the other bio courses that students were taking in these nested models. In terms of like tutoring experiences, we do not have that. So if tutoring was having an impact, then we would basically hypothesize that the students going to tutoring were only of particular demographic groups and the others were not, which seems unlikely just talking to Shannon. Like there's not like a very clear, like you don't walk into tutoring and see just an entire demographic and everybody else missing. So it seems unlikely that could kind of explain the outcomes for that reason. But I think it'd be great if we actually had information on that for every student, because maybe tutoring could actually produce those outcomes.
Okay, any other questions?
Another question.
I have a question.
Yes.
So just trying to understand this maintaining and mitigating, and I'm trying to visualize this space. And if the top people keep getting better, is that affecting your maintaining? Do you know what I'm saying? Like, is there an upper limit in this, or how does that work?
Well, yeah, it's very, first of all, it takes a long time, even as I thought about this, separate from the models, to conceptualize what's happening. It's not simple. The issue is that everyone is running the race, but starting at different points, but they're all traveling the same distance. So basically, those distances are then maintained as you move through. So you're maintaining the distance. It's kind of like you're driving a car, someone else is driving a car, you're both going 65, but that other car started behind you and you're ahead of that car. You'll both keep moving at 65, but that car will always be ahead of you, no matter what, unless you speed up. And so the question is, to get rid of the gap, that car behind you has to go 70, 75 to catch up for you to travel.
Got it. I think what I'm saying is, what if the front car is going 75 and the back car is going 65? Do we know?
Right. That's why the distance measurement is essential. And what we're doing here is we're measuring the distance.
I see. So if you're saying they all learned large, okay.
Yep. They're all exactly. Great question. It basically shows that the speed of everyone, we're getting everyone to 65, or nearly everybody. In most semesters, everyone's getting we're getting them to 65, which is very hard to begin with. But now we need them to get a little more gas. And so how do we do that? And so that's where you need more there. But knowing where you need help. In some classes, there's not much learning happening. For example, at San Diego State, we found the learning was not only small in some classes, it was negligible learning. And my PhD student, this study is actually being done at a couple different universities now for the same learning objective. And what we're finding is at other universities, so far, the learning is not only small, it's negligible. There's almost no learning gains at all in these classes. And this has been found as well for some of the other classes around the country. So, so the kind of the speed you're going differs dramatically across the United States. And one piece of good news is we're hitting the gas nicely at Stony Brook.
We're driving fast. And so now I want to know like what gas we're giving, you know, like do you know, like, did you have anything in that? And there's not much time left. So, but I'm very curious.
Yeah. Well, the gas, we actually wrote a paper on that a few years ago. The class was completely converted to small group collaborative learning with a huge undergraduate teaching assistant program that I developed, where the undergraduate TAs participate in a 1-credit teaching, learning, assessment, and equity class that accompanies their work in this class. And they are basically helping other students. So it's a completely collaborative, supportive environment versus these alienating large lectures that dominate a lot of introductory science classes. And so the gas we're giving is basically active, collaborative, and supportive learning environment. So that's the gas we know we're giving, but we need some, I don't know, high octane, I don't even know what that is, but you know, to take the analogy further, something like that.
Now I'm picturing carrots on strings. I don't know. It's not really gas, but I feel like that scaffolding you're doing in small groups kind of is like that, right? Like the jockey with a carrot, like go, go, go.
Yeah, but it's also getting everybody to be able to learn a lot when people come in with vastly different starting points. That's very hard. So yeah, great
It sounds
question.
like you're using your class knowledge well, though. People who know stuff, you're using that.
Yeah, exactly.
Right? People come in with higher levels, and that sounds really smart. Love it. I like it.
Well, I think this is another thing where faculty can really make a difference. Faculty should be able to help students learn. And without knowing what's happening with learning, it's very hard to help faculty change because you don't really know what to focus on. Should you focus on belongingness? Should you focus on, inclusion? Should you focus on learning? But faculty know the most about learning, but there's almost no emphasis on learning. And I think learning is part of equity, according to the National Academy of Sciences. And I feel like learning is a missing variable, but here we've brought them together. And so I think the solution is integrating our knowledge of equitable teaching practices and effective learning practices. Together, I think, well, we know it can have good impacts. So.
Okay, we're at time. I want to say thank you so much to Dr. Nehm. We're going to share these slides with you, and we hope to see you at further events for Love Data Week. Thank you.
Great. Bye, everybody.
Bye.